Okay, let's say we have a plane here. We have a point P out here, and we want to find the distance from the point P to the plane. First thing we do, we need to find a point on the plane. Could be any point on the plane. So Q is any point. On the plane. P is some point outside the plane. Now, what we're going to do is we're going to say, okay, well, from this point, we have some normal vector. So let's just say, we know what our normal vector is. It's normal at any point of the plane. So here's our vector that's normal to the plane. And then we have the vector that we'll construct. Now that we have a point Q, we just construct the vector QP. Now the distance of the point from the point to the plane is a distance from the point to a point on the plane where the vector from P to that point is perpendicular to the plane. We can find the length of that vector by simply projecting the vector QP onto the normal vector. So now we have the scalar projection. I don't even have room to, so I'll write it out. The projection of the vector QP on the normal vector. Okay, so now we have a vector, well, we have a projection of the vector from here to here. We have the projection of P onto this. Now this projection makes a right angle, so that if we took a vector from here to here and dropped it from P down to the plane, the end of the vector would be on the plane, and we would have a vector whose length is equal to the distance from the point P to the plane. So this projection, if we take the magnitude of this scalar projection, let's say, or the magnitude of the vector projection if you wish, doesn't matter, we get the distance from the point P to the plane. And then we can say that the distance from the point P to the plane is the magnitude of the projection onto N of the vector QP. Now, there's a formula that goes with this, and the formula is a little bit longer than this, but if you know what a projection is, you don't need that formula. You just have to notice, first of all, it's best if you understand this picture. But even if you're just memorizing a formula, this is a lot easier to memorize and is much more informative than the formula you see in your book. Now, the formula you see in your book was derived by this. I'm just telling you that even if you're memorizing formulas, this is much more economical to remember than the formula given in your book. And you can apply this formula very easily if you know how to do a projection, and that, of course, is quite simple. Okay, so just an idea that it's more economical to remember something that has some content than it is to memorize a long formula when you don't know what the parts of the formula mean. Now, if you can look at this picture and see that formula, that's fine. You really want to have this picture if at all possible. But once more, even if you're just blindly memorizing things, better to memorize this than to memorize that formula.